Right then, so this is a presentation on some of the health and safety aspects required when operating forklift trucks. So we're going to run through the legislation to start with. We've got the Health and Safety Work Act, which, as you can see, is an act. It's an act of Parliament. This therefore means that you are legally bound to follow the advice highlighted in here, or follow the points stated in this. We've then got the provision and use of work equipment regulations, or what we refer to as PUWER, P-U-W-E-R. This is a regulation similar to the next one, which is what we call LOLA, lifting operations, lifting equipment regulations. Both of these regulations is what we call guidance, put forward by the Health and Safety Executive. You are not legally bound to follow the points highlighted in these. However, if a court finds you at fault, finds you not following these regulations, these documents of advice put forward by the Health and Safety Executive, you will then be required to provide evidence of how you conformed to the legislation in some other way, the legislation being the Health and Safety Work Act. So an easy way of thinking about it is the Health and Safety Work Act is the rules that you need to follow, and these two are the advice in how to go about doing that. So as long as you conform to these two, then you'll normally be doing what is necessary to conform to the Health and Safety Work Act. The underlying message that runs through this is that health and safety is everyone's responsibility. Regardless of who you are or what your role is, you are legally bound to do something within the workplace regarding health and safety. So we'll start with the Health and Safety Work Act. This is broken down into multiple sections, section 2, 0 and 8. Section 2 is the responsibility of the employer, 7 is that of the employees, and 8 is that of visitors on site. So when this was introduced in 1974, there was pre-existing legislation, such as the Factories Act. As the name suggests, it applied only to factories, so only those people who were operating there were legally bound to follow what was highlighted in that. The problem with that is that there was lots of people who weren't covered under said legislation, and therefore the Health and Safety Work Act was introduced to provide a more wide-ranging legislation to encompass more people and ultimately, provide safety to more individuals. So now the Health and Safety Work Act incorporates that which was covered under the Factories Act, people who were also covered under the Offices, Shops and Railway Premises Act, teaching establishments, people who are self-employed, visitors and also members of the public. So you can literally walk into any workplace within the UK and be covered under the Health and Safety Work Act, meaning that all parties present have a legal responsibility to consider your health and safety. So the Health and Safety Work Act, as you can see here, it imposes general obligations regarding health, safety and welfare, as I've just suggested. It is also supported by codes of practice and regulations. Again, so these documents give advice to people who are present on site in how to operate or act so that it conforms to the Health and Safety Work Act. And it's these documents are then specific to your individual industry, processes and machinery that you're going to be using, so they give you a bit more of a clear guidance. The objectives of the Health and Safety Work Act is to ensure health, safety and welfare of people at work, as you'd expect and as the name suggests. It's also there to prevent risk to the general public arising from workplace activities. So just for a second, if you consider your workplace, think about how your workplace could potentially be putting members of the public in danger, and consider the things that are the precautions that are being implemented to account for those risks, to account for those individuals. Obviously these have been put in place by the employer to reduce the likelihood of injury to members of the public. The last point on here is then to control the use of hazardous materials in the workplace. So if you are dealing with hazardous materials such as flammable gases or corrosive materials, they need to be handled and stored and transported in a way which doesn't bring around risk to individuals, as per the Control of Substances Hazardous to Health guidelines. Okay, we'll get into the nitty gritty now. So this is section 2. This is the employer's responsibility, and it goes through and states that the employer needs to, wherever reasonably practicable, do the following. Reasonably practicable means that they need to work out whether it's financially viable, what sort of effect is it going to have in the workplace. So, for example, providing everybody with rubber gauntlets, or abrasive protecting gloves to avoid paper cuts in the workplace might not be a reasonable thing to do, whereas to give people abrasive protective gloves when handling abrasive wheels, or using angle grinders or chop saws, for example, that is deemed reasonable. So this is something that the employer would need to consider. They would need to provide and maintain plant and systems of work, ensuring that they're safe and at risk to health. So provide and maintain plans, that's talking about the workplace in which you're operating, the equipment that you're using, and the systems of work. Systems of work refers to sort of method statements, or what a lot of people call toolbox talks or SOP, systems of practice. It's just the methodology by which you go about doing the job. So for example, before you use a piece of equipment in the workplace, you are required, or it's advisable that you go through and check the condition of it to ensure that it's safe for operation. Next point then is make arrangements for ensuring the safety and absence of risk to health in connection with the use, handling, storage and transportation of all articles and substances. So what you need to do, what the employer would need to do, is to make sure that let's talk about handling. The way in which items are handled in the workplace is done in a safe way. So if you are manually handling equipment, i.e. picking up boxes and transporting them around the workplace, then you need to do it in a way which is not going to bring around risk to yourself. So ensuring that you are operating with good manual handling techniques. When we talk about transport, if we're talking about a forklift truck and it's transporting a box from point A to point B, you need to do this in a way which is again not bringing around increased risk to the operator or people within that space, pedestrians for example. So this is the employer's responsibility, remember. The operator would also be legally bound to do that, but in this instance we're just talking about the employer's responsibility. So the employer needs to make sure all handling techniques, all methods of transport are done in a way which is not putting people at risk. I hope that makes sense. The employer also then needs to provide information and supervision, ensuring that people are aware of the correct methods of practice and they are supervised when doing that. Training and instruction, so this presentation is contributing to your training, and instruction would be what you'd expect to receive moving forward. Ensure the health and safety of employees and visitors. This sort of goes without saying, and as the legislation title suggests, it's the employer is required to make sure people are safe within the workplace. And ensure that places of work are safe from that risk to health. So we're talking about no exposed asbestos, no open flames, those sort of things. Also provide risk-free means of access and egress, so anybody on site is able to, if at any point need, exit the premises without any sort of physical hindrance, i.e. nothing pushed up against the fire door, forklift trucks not parked on pedestrian walkways making them inaccessible. We've then got provide facilities and arrangements for welfare at work, so safe drinking water and toilet facilities, those sort of things, and then prepare and publish a written safety policy. So the employer is legally required to go through a risk assessment and establish what hazards there are in the workplace, and then implement some sort of precautions to ensure that the risk of that is limited, and then obviously they need to publish this so people on site are aware of that. So that's the employer's responsibility. Section 7 and 8 looks at that of the employees and visitors. So the first responsibility of employees and visitors on a work site is to ensure that they take reasonable care for their own health and safety. So you are legally bound to make sure you are safe. So if your actions are putting you in danger unnecessarily and it's deemed unreasonable, then you could potentially be prosecuted for your actions. So if we're talking about operating dangerously on a forklift truck, then you could be in breach of Section 7 of the Health and Safety at Work Act. We then got, in addition to considering your health and safety, taking reasonable care for the safety of other people who might be affected by what you do or do not do. If you do not use a horn at a blind corner, if you don't make an audible warning, then obviously you're putting people at risk, so obviously you would be required to do that. You are then required to cooperate with the employer in meeting the statutory requirements. If the employer has met those requirements by providing you with, for example, a pre-use check sheet before using the vehicle, and you then do not follow that pre-use check sheet, having already been notified that that's something that you were required to do via your training, then you would be obviously in breach of Section 7 of the Health and Safety at Work Act. So obviously do your checks before you use the truck, nice and simple. Last point here is then to not interfere with, alter or misuse anything which is provided for the purposes of health, safety or welfare. So if we're talking about PPE equipment, for example, if it's provided, then obviously it would be reasonable and fair to expect you as the operator to use that equipment. So for example, we're talking about a seatbelt on a truck, then obviously it would be required for you to wear that seatbelt. When charging the batteries, when they're being exposed to acid, it would be reasonable for the employer to provide you with rubber gauntlets and apron and some sort of eye protection. If they have done that and you then opt not to use it, then obviously you are misusing the PPE equipment and potentially putting yourself at risk. So obviously that would need to be something you would avoid doing. Okay, so that's the Health and Safety at Work Act in a nutshell. That's the ins and outs of that, and obviously that's the legislation which you are legally bound to follow. The provision and use of work equipment regulations, or as you can see on screen, the PUWA, this is advice put forward by the Health and Safety at Work Act, and it states that the equipment that's used in the workplace needs to be suitable for the intended use. If for whatever reason it's not suitable, then it would be reasonable for you as the user to not use it. So if we're talking about using a cherry picker, for example, using that in conditions which are too windy for safe operation of the cherry picker or the scissor lift, then obviously you wouldn't use that. If you are using a reach truck, for example, a vehicle deemed safe for use on flat surfaces, then it would be unsuitable to use them on surfaces which it's not been built for, such as bumpy terrain or rough terrain. So again, if it's unsuitable, don't use it. The equipment also needs to be maintained in a safe condition. To ensure that this remains the case, this would be something that the operator would be required to do. So before you use the vehicle, as we've said previously, check the condition of the vehicle as per a pre-use check sheet. I'm hoping all of you guys are familiar with those, and if not, then we can go through that as part of the training. So obviously ensure that the vehicle is safe before you use it. Otherwise, as you can recall, hopefully, from Section 7 of the Health and Safety Work Act, you'll be able to tell that you are then in breach of that. You've not taken reasonable care of your own health and safety. You've not taken reasonable care of the safety of other people. If, for example, the brakes on the truck don't work and you've not checked it, then obviously you're at fault. So make sure you check the condition of the vehicle before it's used and document that in the pre-use check sheet book. Next point is that the equipment needs to be used only by people who have received adequate information, instruction and training. So if you haven't been instructed or informed or trained in how to use the equipment, then obviously don't use the equipment. Remember, this is the provision and use of work equipment regulations, so this involves all equipment in the workplace. We're talking about abrasive wheels, we're talking about ladders, we're talking about anything that you might be required to use. If you're using a drill or a chop saw, then obviously make sure you know how to use it before you do it. The last part on here then is accompanied by suitable safety measures. So for example, protective devices, markings and warnings. This is obviously going to be dependent on your vehicle, The protective devices that are present may be different to those which are present on another vehicle, but generally minimum requirements would be that the vehicle has some sort of audible device, some sort of lighting system, so a beacon, so there's a visual notification for pedestrians that the truck is operating in an area. Obviously some vehicles have considerably more lights, so you might have a blue spotlight which projects a light onto the floor a few meters ahead of the vehicle, so that when vehicles are exiting aisles, pedestrians in the transfer aisle can see the vehicle is arriving via the blue light before the vehicle actually gets there. Markings and warnings we've got here as well, so again it's always going to depend on the vehicle, but as standard, your markings and warnings, we're talking about stickers on the vehicle to notify pedestrians of what's safe and what's unsafe, and to the operator as well. So some vehicles might have a sticker on the mast to notify pedestrians not to stand on or beneath the forks. It might have a sticker within the cab notifying you to not jump out of the vehicle if it was to turn over, that sort of thing. And then we've got Lola. So Lola is a bit more specific now to forklift trucks, in that it's talking about lifting operations and lifting equipment regulations, whereas Pure was talking about all work equipment. Lola is talking about only those which have a lift function. So for example, we're talking about forklift trucks, we're talking about stair lifts in care homes, we're talking about elevators in hotels. It covers a whole range of different things. Now what this states is the equipment would need to be strong and stable enough for the particular use. So as part of your pre-use check sheet, you go through and establish whether the condition of the vehicle is strong and stable. So if we look at the strength of it, if we look at the forks, for example, if there are cracks or defects in the forks, if it's bent or twisted, that might indicate that it has insufficient strength. As part of the test that an engineer would come in and do, they would check the thickness of the fork and ensure that the fork heel has not been worn down by more than 10% of the fork face. So if the fork face, or the back of the forks, is 100mm, then it's expected that the heel of the fork would be at least 90mm. If it's below 90mm, then the fork should not be used because they are insufficiently strong. Stability looks at, if we again still take forks as the example, if we're looking at stability, we'd need to make sure that the forks are in a condition that the load is going to be stable, so they're not bent so much so that the load becomes uneven, becomes twisted or anything like that. We also need to make sure that the pins are located in to prevent the forks from sliding around during transport of the load. The next point then is marks to indicate the safe working loads. So you should be able to, as the operator, at any point determine the safe lifting limitations of the vehicle. So you need to know whether the 2.5 ton load in front of you is going to be too heavy for your vehicle to lift or not. So your rating plate will have it clearly marked on. It will tell you the maximum lifting capacity, maximum lift height, and also the maximum load center. The load center being the maximum distance the truck can hold the maximum weight that has been highlighted from the front face of the forks. So conventionally it's either 500mm or 600mm. So if the truck states that it can carry 1,000 kilos, it will only be able to carry 1,000 kilos as long as the load is not, or the centre of gravity of the load is not more than 500mm away from the front face of the forks, i.e. the load hasn't been undercut excessively, or the weight isn't unevenly distributed so that the weight is at the tips of the forks. So you need to make sure that you fully heel up the load when lifting, and making sure that it does remain within that correct load centre. Also, as the height increases, the maximum lifting capacity may also be affected by that. So the rating plate might have derated values on there, so the higher you go, the less weight you can carry. Similarly, As you increase the load centre, so let's say from 500 to 600 to 700 millimeters, the lifting capacity may be affected by that also. So you may only be able to lift 800 kilos at a 700 mm load centre compared to 1000 kilos at a 500 mm load centre. We've then got positioned and installed to minimise any risk. Now you can't really install a forklift, but you can position it, so make sure when you're picking up a load, the load is positioned on the vehicle in a safe manner, as I've just described, to make sure the load centre is as small as possible and not exceeding the maximum load centre highlighted on the rating plate. You also want to position yourself, as close to the load as possible, so you're not, when dealing with a reach truck, you're not transporting, also you're not manoeuvring with a reach extended for unnecessary distances, over unnecessary distances. The equipment should be used safely, and work should be planned, organised, and performed by competent people. That terminology there is important, competent people. So this competency can only be determined by the employer. So the employer would say whether you are either competent or incompetent, and they would, it would be reasonable for you to expect them to give you written authorization to use the equipment before it's used, obviously deeming you competent. Last point then is subject to ongoing examination. Ongoing examination referring to the pre-use checks that you do before using the vehicle, and where necessary or as appropriate, inspection by a competent person. This inspection by a competent person is a not a pre-use check, sorry. This is a annual inspection performed by a mechanical engineer. So they will go through and very, methodically determine the condition of the vehicle. If the vehicle is deemed unsafe, i.e., as I've suggested earlier, the fork heel is worn down by more than 10%, and therefore indicating that it doesn't have the necessary structural integrity to lift the weight which has been stated on the rating plate, they would then deem the forks unsafe for use. So the vehicle would be unsafe for use without any amendments to the forks, i.e. replacing them. The frequency of these checks, so it says here, as appropriate, the frequency of that would be dependent on the vehicle. So vehicles that are going to be lifting people up in the air, any lifting equipment which lifts people will need to be checked on a more regular basis, i.e. a minimum of every 6 months. So if you have a non-integrated working platform, or what people call a lifting cage, that lifting cage and the vehicle that is lifting it would both need to be checked within the last 6 months. I hope that makes sense. Now, if there is an issue within the workplace, what would happen is these guys, the health and safety executive, these would come in and they would perform an investigation. So obviously, if we're talking about an instance in the workplace, this would need to be reported under the reporting of injuries, diseases and dangerous occurrences regulations, or RIDDOR, and the health safety executive would then determine whether it was necessary to investigate or not. If they did feel it was necessary, they would come in and establish whether there was any sort of negligence, let's say, which has resulted in the accident occurring. So they would come in and perform the inspections, take witness statements and so on and so forth, and then potentially carry out enforcement functions where required. So up until 2008, it was the Health and Safety Commission who actually produced the regulations and codes of practice, and it was the Health and Safety Executive who then actually enforced them, so to speak. But now the Health and Safety Executive perform both roles as these guys have merged. What are the basic principles for the lift truck stability and safety? So we'll run through a couple of things here. So we're looking at these 5 different points. So we'll look at the seesaw principle. You can see there's a load here of 100 kilos and there's a counterweight here of 100 kilos. The fulcrum is positioned equidistant from both points, so therefore it's balanced. However, this is also balanced, so despite the weight being considerably higher here, because the weight distance from the fulcrum has been reduced, this is the same downward force as what the counterweight would produce. So if we wanted to cause this load to tip off for whatever reason, what we would need to do is we need to pull this further forward towards the end of here, and obviously it would cause it to tip. So hopefully this has sort of made it clear that you can carry a heavier load safely as long as it's closer to the fulcrum point. So when we're talking about a forklift truck, that would be closer to the heel of the forks, so that's why we need to make sure that the load centre is as small as possible. So regarding that, it would need to be the centre of gravity of the load that we're referring to. So the centre of gravity is the point at which an object's weight is balanced in all directions. So if we're talking about a solid concrete block, it would be slap bang in the middle of it, assuming that the weight is distributed evenly. Cylinder, exactly the same, it's a slap bang in the middle. However, what may happen is if we're dealing with a box or a pallet here, if the weight inside of that is able to move around freely, if we're talking about a pallet of stones or pebbles or whatever, then obviously the pebbles may be unevenly distributing the weight beyond just one side. So we need to consider that when we are performing a lift, to ensure that the centre of gravity isn't too far towards the tips. So if the pallet was being picked up from this edge, then you'd want the centre of gravity to be closer to this side. So if the weight is all over this side, then you'd need to enter the pallet from this direction, not from this direction. If we're dealing with a cylinder, often we use barrels and they will contain liquid. Then we're dealing with a live load, similar to what I've just described here. A live load is anything that has the ability to move its centre of gravity. Highlighted more specifically with cylinders because we were talking about liquid, and obviously the nature of it, it's more fluid and it's more prone to moving around more easily. So obviously you need to make sure you're operating more cautiously when doing that. Right, so we need to be aware of where the centre of gravity is in the vehicle. So with this being a counterbalance truck, it's the same with a reach truck, that the weight is nearer the back of the vehicle. So when we add a load, what's going to happen is, as you can see here, the load brings the centre of gravity of the vehicle plus the load, i.e. the combined centre of gravity, further forward. We need to ensure that adding that load doesn't bring the centre of gravity of the truck plus the load too far forward, because if it does, if it brings it outside of the base of the vehicle, the base being between the wheels, then obviously that's going to end up tipping the vehicle forward. So the load weight cannot exceed that of the counterbalance without tipping it over. So if, for example, it goes too far forward like this, it's then exceeding the safe working load of the vehicle, and the truck is therefore deemed overladen. So what we need to do is make sure the centre of gravity stays over the base. Really easy. If we're dealing with live loads, like you can see this is 4 individual units stacked up, then we would need to make sure that these are banded to reduce the likelihood of this happening. So the stability triangle, this will be described more in the video that you'll watch later. The stability triangle is the footprint or the base of the vehicle. So from point A to B to C, this is where the centre of gravity needs to remain. So you can see it's narrow at the back because the rear wheel is on a fixed axle like this. So the centre of gravity needs to remain within this triangle. With the nature of this being narrow at the back, with the load, with the centre of gravity here closer to the back, it's more easy to cause this to come outside of the triangle in this direction, to the left and the right of the vehicle, as the operator would look at it. So placing a load on the front of there would cause the centre of gravity to shift forward and give the vehicle better lateral stability, left and right, because this centre of gravity moves further forward. It's got a greater distance to cover to move outside of that triangle. The further forward this goes, the less longitudinal stability it has. So longitudinal being this plane of forwards to backwards. If this was further forward here, it would only require a slight movement of it further forward to then come outside of the triangle forwards. I hope that's clear. This is the point I've just mentioned regarding this rear axle. So it's a triangle because of this rear axle. So movement of the centre of gravity within the stability triangle is going to affect the stability. So we need to be aware of how and why that occurs. So there are an array of different forces which affects the vehicle. So lifting or lowering the load, that can affect the centre of gravity, particularly if it's done in an aggressive way. So the higher you lift the load, the more exaggerated the movement that occurs. So if you were to lift up, and as you can see on the next point, if you were to lift up and then tilt further forwards, the forwards movement would be exaggerated because the loads are much higher. So obviously you don't want to be driving along and with the load up in the air. Use of side shift. This is obviously very important. You need to ensure that the side shift is within the middle, or it's at the centre point before operation. Obviously if you've got the side shift all the way over to the left and the weight is further over to the left, performing a turn to the right hand side is going to cause the truck to be more likely to tip over to the left. Accelerating or braking. I hope this is obvious. Braking harshly is going to cause the truck to tip over more likely anyway. If you were to be turning sharply or at speed, this is going to increase lateral instability, so that would be advised not to do that. Driving on slopes or gradients, so you would need to ensure that the orientation of the vehicle is correct when driving on slopes or gradients. So if you're driving with a load up a hill, you'd want the load to be facing uphill irrespective of the direction of travel. So the load would always face uphill. If you're driving up the hill, you'd want to then obviously be driving forwards. If you're driving down the hill, you'd obviously want to be reversing to ensure the stability, traction and adhesion of the vehicle to the road and of the load to the vehicle, so it's less likely to lose the load or the truck to tip over. We also don't want to be driving across a slope because one, trucks aren't built to do that, and two, the truck's more likely to tip over and the loads tip off. Point here we have is rough use of the hydraulics. Obviously any rough or disjointed movement is going to increase the likelihood of the load tip over. And the last point there, picking loads up not to the heel of the forks. So as described earlier, this is what we call undercutting. So if the load is undercut, it's increasing the load centre unnecessarily and increasing more longitudinal instability, increasing the likelihood of the load tipping off. So combined central gravity is the central gravity of the load of the truck plus that of the load, gives you the combined central gravity, as you can see here. As the combined central gravity moves forwards, so from E towards F, the more likely the load is to tip off and the truck to tip over. Sideways instability, we need to consider what factors could affect that. So, what are they? Well, we'll go for that in just a second. Longitudinal stability, exactly the same. You need to always consider what the longitudinal stability factors are when you are operating. So hopefully, based on this image, the direction of the vehicle, looking at this stack, it's clear to see that the central gravity of the load has caused the combined central gravity of the load and the truck to move too far forward outside of the footprint of the vehicle, and it's going to cause it to tip over. So what factors might have caused this to happen? One of them could have been going down the slope as described previously. The correct way here would be to turn the vehicle around and either reverse down or drive forwards up the hill. So you can also cause the central gravity to be elevated, and it's going to increase the likelihood of the truck tipping over. So when travelling with a load at height, it reduces the truck's stability, causing it to be more likely to tip. This is obviously even more dangerous when turning with the load in the air as well. So you need to be aware of the limitations of the vehicle. So on any vehicle there should be a clear, legible clean and accurate rating plate. The rating plate would go through a whole range of bits of information, but what we're going to look at right now is the lifting limitations. So you can see in this point here, this gives you the maximum load height. So load height is point A, as you can see here. It's the distance from the floor to where the forks are. In this instance, it's 3,300 millimeters. The maximum load weight is going to be 1,380 kilograms, as long as the load center remains at 500 mil. The load center being B. B is the distance from, as you can see, this arrow is the heel of the fork to the center of gravity of the load. So as the load moves further forward on the tip towards the tips of the forks, or from 500 to 600 to 700, so from point here to further out, the maximum lifting capacity of the vehicle decreases from 1,380 kilos to 1,130 kilos. So you end up losing 250 kilos of your lifting capacity just by increasing the load center by 200 millimeters. Another way in which this information can be displayed is via a table like this. So again, the same principles apply. As the load center increases from 500 to 600 to 700, the lifting capacity decreases from 2,500 kilos to what looks like approximately 1,800 kilos. So it's really important to appreciate how the load center affects the maximum lifting capacity. Again, load center is the distance from the front face of the forks to the central gravity of the load. Another busier way of doing this, as you can see here, is going through the load center 500, 600, 750, 500, 600, 750, and also describing both how the weight is affected and how the height is affected. So what we have here is the height in millimeters, there, and there, and also in inches, but we'll focus on millimeters, and we'll also focus on kilograms, not pounds. So at a 500 mil load center, this vehicle can lift a weight of 2,500 kilos up to 3,300 millimeters. If, however, the load needs to be lifted up to 4,200 millimeters, then it would need to reduce the weight from 2,500 to 2,450. Otherwise, it will then exceed the limitations of the vehicle. Still using this example, as you increase the load center, it decreases. If you increase the load center from 500 to 600 mil, it would decrease the lifting capacity from 2,500 to 2,260. So being aware of how the load center affects the lifting capacity is really important, and is something that we definitely need to know. So as the load center distance increases, the lifting capacity decreases. Load center increases, lifting capacity decreases. Nice and simple. So what is one of the main causes of forward instability? We've got, firstly, overloading the vehicle, lifting too much weight, real simple. You've got undercutting the load, so not picking up the load to the heel of the forks. So you always obviously want to make sure that you fully butt up to the load that you're lifting. We've got tilting forwards with a raised load, goes without saying. raising a load whilst facing downhill. We don't want to do that. We always want to make sure we turn around so the load is facing uphill. We've then got harsher sharp braking, rough use of the hydraulics, travelling the wrong way on a slope, which we've just mentioned, hitting overhead obstacles, trying to avoid that, make sure you're always looking up before you move. And then we've got sideways instability as well. So we're talking about turning sharply or turning at speed, turning on a slope or on a gradient, lifting a load whilst sideways on a slope, driving over obstacles, or similarly driving into potholes, turning with a raised load. That's the primary cause of trucks tipping over and operators becoming severely injured. We then got picking up a load off centre. So you'd always want to make sure that the load is centrally placed on the forks, the weight is evenly balanced, those sort of things. Incorrect use of side shift, so side shift again, always in the middle to avoid lateral instability. And then we've got travelling with a live load. Importantly, a live load can cause instability in both forwards and backwards direction, as well as left and right direction, so longitudinal and lateral. It just depends on where the load happens to shift. So if we're talking about a bag of sand, that can obviously swing around all over the place if the forks are through the hoops. Now remember, if you are operating a forklift truck, an unladen forklift truck, a truck carrying no load, will tip over to the side more easily than a laden lift truck with the load in the correct travel position. So because of the stability triangle we saw earlier, it's narrower at the back. If you put a load on the front, it pulls the centre of gravity, the combined centre of gravity of the truck and the load, further forward where the triangle is wider, so it's less likely to move outside of that triangle. So carrying a load makes the truck more stable laterally than a truck without a load, and it may very well cause this to happen. This is what they call the mouse trap, where the rollover protection system actually pinches the operator's limb. So you need to obviously make sure this doesn't happen. You go about doing that by making sure that you stay within the confines of the truck, and also brace your feet, hold them tight to lean away from the point of impact. So on some vehicles they're going to have handles for you to hold on to when doing that. More often than not, it's just going to be the steering wheel. I would strongly suggest holding onto the steering wheel and leaning away from the point of impact. That rollover protection system is there to save you in this situation. So if the truck tips, it's not gonna roll. It's simply going to land. It's going to do a 90-degree tip, hit the ground, and then you're safe. As long as you do not try and jump out of the vehicle or jump out in the opposite direction, you are going to be safe. So do not jump out of the vehicle regardless of the situation. There we go, let's avoid that. So in this instance, you'd want to make sure that you stay within this. You wouldn't want to try and jump out here, because if you do, this overhead guard is potentially going to pinch you. And if you try and jump out this way, what may very well happen is your shift of weight may cause the truck to tip back this way and then cause you to be caught as well. So it's just best to stay within the confines of the vehicle. Now very quickly, just to finish, there's some data from a few years ago put forward by the Health and Safety Executive, and they stated that the forklift trucks were involved in 24% of all workplace transport accidents which resulted in injury, which is quite a considerable amount. In that year, it was 8,000 incidents, and that was a 5% increase on the year previous to that. So due to more online shopping, it seems relatively reasonable that there'll be a lot more logistics involved, a lot more forklift operations, and therefore probably more accidents. But that's just what I imagine. There's no sort of stats on that. In that year alone, there were 8 fatalities caused by forklift trucks, which is equivalent to 1 every 6 weeks, which is crazy. In that year, 360 major injuries such as fractures and amputations, 906 serious injuries where people required more than 3 days absence from work, and these generally rates of accidents would increase from September. So it might be worth considering some of the reasons why that may happen. Places becoming busier, people working longer shifts in the run to Christmas, those sort of things. It's an interesting point to consider. It gets darker, weather becomes worse maybe. There's a whole wealth of different reasons of why that may be happening. Some of the reasons for accidents generally: poor workplace design or bad layout, maybe insufficient labels or warning signs, pedestrian walkways not marked out clearly, poor safety awareness and inadequate training, so people not being aware that there are forklifts operating in the area or knowing how the forklifts are going to be operating. Operators not knowing how to operate safely, not knowing how to use the horns, not going through previous checks, those sort of things. Fork height is another major one people often get wrong. Excessive speed and bad driving habits, that goes without saying. People driving too quickly got to be far more likely to have an accident. And then we've got poor observations. This can be both the operator and also pedestrians. So these are some of the primary reasons why people do have accidents in the workplace. other consequences of this: injuries, as we've seen in the statistics as highlighted, potentially prosecutions, and ultimately fines and up to potentially 5 years in prison. So I mean, we are dealing with potentially some really serious consequences, so it's always best to make sure that you operate safely, nice and easy. So the key take-home messages from this: we've got, make sure you perform good observations at all times. Do not use the hydraulics when moving. Instead, you'll want to stop, apply the handbrake and select neutral to ensure that the truck's not moving. There you go. There you go. And then operate the hydraulics smoothly in not in a disjointed manner. Obviously, using rough hydraulics is going to increase the likelihood of the load tipping off. Travel with a load to the heel of the forks so the load is not being undercut. You don't want to increase the load centre because that's going to reduce the stability of the vehicle, cause the load will increase the likelihood of the load tipping off and the truck tipping forwards. And never turn with a load or forks raised. Again, the primary cause of trucks tipping over, particularly dangerous. Do not do it. Operate safely at all times. Why? A good operator is a safe operator. There we go.